Hello everyone, Mr. Hein, and I am back. And today we're talking about 3-2-1, the definition of the derivative. And derivative is a huge word. Give that 4 stars and you're going to learn what that is today. And in fact, you've been doing it. I just haven't introduced the word yet because this word, we don't know what this word means. And there's ways we could describe it without, go into this abstract language. So let's recall before we start talking about what the derivative is. Let's recall the power rule. And we learned in the last video that the power rule says for any polynomial f of x equals a times n, apologize, a times x to the nth power, the slope function is f prime of x is equal to a times n x to the n minus 1 power. So what we learned is that for any polynomial function, we can actually analyze its slope with a new function as follows. And that's fascinating because you have a whole function where any point at this function, like you want to find what the slope function at 1, well, that's the slope of the function f of x at 1. So this whole function defines the slope, the rate of change of the previous function at any given moment. That's very, very awesome stuff when we talk about understanding rates of change. Right? And then also recall that we learned how to go from AROC to IROC, where AROC is your average rate of change to the instant rate of change. And the way we did that was average rate of change is just the slope between 2 points. And how can we use that knowledge to get the instantaneous rate of change? Well, you take those 2 points and you take one point that's h away from it and you just approach 0. So the IROC would be you pick your points that you pick is you pick a point. So say we pick a point a comma f of a, and your other point is a plus h. Apologize, I'm making some mistakes. A plus h, and then the function at a plus h is the y value. Where remember that this is some point that's h away from it. That's h away from a. And I'll do a curve here to help you visualize it. So you have a curve, arbitrary curve, and you have a point A, and then you have another point A plus H, which is some point H away. And what you want to do is if you want to find the instant rate of change at A, what's the velocity, what's the rate of change at exactly that moment A, what's the slope at A? Well, what you're going to do with the slope between these 2 points is you're going to minimize that slope down to 0. So what it becomes is the limit as h approaches 0 of the slope between these 2 points, which is f of a plus h minus f of a over a plus h minus a. So it's the slope between the points minimizing the distance between them. So again, this minimizes the distance between them. And this right here, this whole thing is the slope between 2 points. Now, they do simplify that always, where what they'll write is the limit as h approaches 0 of f of a plus h minus f of a. And then what they always have is just over h, because recall that if we did a plus h minus a, the a's will just go to 0. Okay? So that's where we're coming from. Now, one thing to know with this previous example is notice that we picked a point to its right. And there's actually 3 ways to get the instant rate of change. So there's 3 ways to get the instant rate of change. And do note that they're all correct. It won't matter which one you choose. All right, one of them is more conventional than the others, but they're all the same. So the first one is, like I just did up here, you have an arbitrary curve. and let's say we call our point x now, and then you pick another point that's to the right of it. So this is picking your second point to the right. And the way you can get IROC in this situation, let me bump that up a little bit, is it's the slope between these 2 points. So it's going to be f of x plus h minus f of x over x plus h minus x. And then the way you get the instant rate of change is you just have the limit approach 0. So both parts are needed. You can't just have this. If you just have that, that's average rate of change. You just have that, well, that makes no sense. The limit as h approaches 0 of what? So you need both of them together to be the instant rate of change. And again, the simplified version, and this will be the last time I write the x plus h minus x. Well, maybe not. Maybe all of this video I'll keep using that for h. So that's one way you can write this, and that's to the right. Second way you can write this is, and some of you are already thinking this, is do you have to pick a point to the right of it? So if we have a point x, do you have to pick a point h away to its right? No, you don't. And that doesn't really change things because limits, if it's continuous, the function will approach that point from either side. That's how the limit exists. So let's pick a point x minus h. So now it's h away, but the second point is h away to its left. Right? That doesn't matter. And if you wanted to find the slope there, this will still work, and you'll have the limit as h approaches 0 of, now typically it doesn't matter order in the end, it will balance stuff out with positive negatives, but I'm going to call that the second point because this is an increasing function. So it's going to be f of x minus f of x minus h over h. And the reason I can just do h again is, say I back up a step and I write this full thing out. It would be f of x minus h over x minus h. We'll notice that the negative one, after it gets distributed, the x minus x will go to 0, and you'll just be left with h, positive h, because the negative will distribute to that. Right? So there's your second way you can do it. So one's from the right, from the left, and then the third option you can do is you have a point x, and this is what a lot of you were saying during our Zoom on Friday, is instead of even using this point, is we can actually approach from 2 points, one from its left and one from its right. So now the third approach is you pick 2 points on both sides and close in, and close in. So what that would look like is that's going to be the limit as h approaches 0 of, and I'll use this point first, though it does not matter, minus f of x minus h, the y values at these points, over x plus h minus x minus h. Hopefully you're catching on that it's just the slope between 2 points, and we're minimizing that distance between them. And then if you simplify that, you have the limit as h approaches 0 of f of x plus h minus f of x minus h all over x minus x will go to 0, h, now that minus, once it distributes that negative h, will make plus h, so h plus h, you actually get 2h. So this definition is slightly different because we have a 2h. Sorry, I didn't realize my face was blocking it. But all three of these work, right? They're all correct. And it doesn't really matter. What's more important is that you understand the idea is to get the rate of change on a curve. Now remember, we're doing this on a curve. If it was a straight line, you don't need this method because the slope between 2 points will be the same. But if it's a curve, has some sort of curvature to it, any of these will work to get the slope at a point. Now I'll say right now, and I'll highlight it, this method where you pick a second point to the right, method 1, is conventionally the most common. So this is the most common. And this is what I will be using, as this is what, again, being the most common, the most conventional, what they'll be using. Now notice that the IROC here is how you get the slope at a particular point. The slope at a particular, or the reason it's called IROC, again, it's an instantaneous point. So that's the slope at a particular point. Now, if you want to get the slope at any particular point for the entire function, in other words, if you want to get the slope function, right? The slope function is a whole function where every point represents the slope of the function f of x at any given point. What that's called is, what that's called, I guess they're the same thing, but IROC, that word that when you use IROC, is equivalent, is the same thing as the word derivative. And that word right there, derivative, is a big word that pretty much is what you'll be seeing mostly in this course moving forward, rather than IROC. They're not going to say find the instant radius of change. Sometimes they'll say find the derivative. And derivative is just the same thing as the instantaneous rate of change, right? So the definition of the derivative definition is a derivative is the rate of change at a particular point, if that's the derivative at a point, or it's the derivative. Another word you can think about is the slope function. It's the same thing as the slope function. All right, that's another way of saying it. So this is an informal definition, not necessarily the formal definition, but just helping you understand what derivative is. It's the rate of change at a particular moment. That's why it's the same as IROC, or the derivative can also be known as the slope function. And what they always use here is the definition is the limit as h approaches 0 of f of x plus h minus f of x over h. And this right there is the formal definition of the derivative. If, I might preface this, if f is continuous. So if f is continuous, then the derivative can be categorized by finding the limit between 2 points. Now the reason f has to be continuous, because if it weren't, well, the limit doesn't have to exist, which this whole thing could fail, right? So there it is. Derivative is what you've been doing this whole time. It's the same as the IROC, and we've done this definition just previously. Right? Now let's apply it to, well, let me add one more thing before I finish this. So derivative is the rate of change at a particular point, or the derivative can also be known as the slope function, vice versa, the slope function can be known as the derivative. Now keep in mind, it's also the slope of the tangent line. And that's just a third way they might say this, right? Because the tangent line is the line that intersects one time. Well, the slope of that is the rate of change. So that might either be a way you can think about derivative. So it's kind of a lot going on, but the big thing is it's the rate of change at a particular moment. Understand that and you should be good. And then the whole function, which is f prime of x, is the slope function, where this entire function represents the rate of change at any given moment of that original function f of x. All right? So let's keep going. Let's take this idea and run with it. And here we go. Let's do this problem that you're going to see here, and I'm going to try to keep that right there, the derivative, as I add a new paper here. Now, let's look at this example and say, okay, we have a function. If f of x is equal to 6x squared plus 3, what's f prime of x? Right. Now, we can use the power rule. That's one approach here, because it's a polynomial in which we get f prime of x is equal to 12x, and that's it. And that works. Or you can use the definition, I'll just say use the definition of derivative. Use the definition of derivative, which again means we're going to do f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. Right. Now, one thing to know before I do this second method, so that's option 1 or option 2, right, is that the power rule, you'll see it's really quick and that's great, but the power rule is a shortcut. All right. It doesn't always work. If it works, great, but it doesn't always work. The definition always works. All right. And I'll put a little quote on always because in our class it will always work. There are moments when you get into a little bit more complex functions where you need a little bit more tricks, but the idea is still the same. So power rule is such a shortcut. Remember that the definition always works. All right. So if you ever don't know what to do, know the definitions. That's why they're always the building blocks of math. Right. So let's do this here and see if we get 12x. So then what we have here is f prime of x is equal to the limit as h approaches 0 of, we plug x plus h into that function, it'll be 6 times x plus h squared plus 3 minus f of x, which will be 6x squared plus 3. And I would do parentheses around those two to make sure you don't make any algebra mistakes over h. Keep going. We get f prime of x is equal to the limit as h approaches 0 of, now this will be, I'm going to multiply this out, so that's going to be 6x squared plus 2xh plus h squared plus 3. And now I'm going to distribute that negative over minus 6x squared minus 3 over h. F prime of x is equal to the limit as h approaches 0. Now, keep in mind, I'm writing the limit as h approaches 0 every time. You need to do that. If you don't write the limit as h approaches 0 at any given moment, say you just write f prime of x is this, and you just keep going along these steps, you will get docked on the AP exam if you choose to take it, because at that point, you're writing a statement that's not true, right? The slope function is the limit as h approaches 0 for any x. For any x, we're finding the slope at a particular moment as we minimize that distance between 2 points. Without that limit, you're just finding average rate of change, which is not the same thing. All right, so make sure you always include the limit. I've seen that as a very common mistake that many students have made on AP exams. So keep going. That would give you 6x squared, which would cancel out with negative 6x squared. Next would give you 12xh. Then we'll have plus 6h squared. That plus 3 and minus 3 will cancel, so we're left with over h. And then from there, we can factor out an h and get 12x plus 6h. And you should always be able to factor out h because you need that bottom h to eliminate. If that bottom h doesn't eliminate, you made a mistake somewhere because you can't plug in 0 to evaluate that limit. So now if you plug in 0 for h, that would go away, and notice you're just left with 12x, which is the same thing we got with the power rule. And you can see why the power rule is a nice shortcut, but this always works, right? And just to emphasize, so just to make an emphasis on this point. So the original function f of x, if we graphed it, it would look something like this, where this is at 3. And f prime of x, the derivative here, the derivative of f of x is represented by 12x. So it looks something like this, just a linear line with a slope of 12, right? Now what's happening here is if you find the slope at any given moment, if you plug a number in, sorry, I lost you on my paper. Right. So say we wanted to find what's f prime of 2. Well, if we plug 2 into our slope function, it would be 12 times 2. We get f prime of 2 is equal to 24. So what that means is at 2, we're at 24 on our slope function. Now, what's that mean on f of x? That means that at 2, the slope, the rate of change at 2 is 24. So that means that the slope of f of x at x equals 2 is 24. And again, slope, rate of change, IROC, the slope of the tangent. They're all saying the same thing, just different ways of understanding it. And there it is. And you could use f prime of x to get the slope of fx at any time, relating quadratics to linear, which is very powerful, right? Because now if you're given any amount of something, now you can analyze its rate of change at any given moment. And in fact, if you keep going, then you can analyze the rate of change of its rate of change, and you can analyze its rate of change of its rate of change, and you can keep going. Now, I'm not going to get into in this video, but more or less, you can say, if you have the amount of water that's being emptied from a pool, well, just by knowing the amount, you could find the rate at which it's being emptied, the velocity at which it's emptying, and then you can analyze the rate of that, which the rate of velocity is acceleration. So now you analyze the rate of the original function. And you could keep going, you can analyze the rate of that, but we don't really go to the fourth rate because we don't really, as humans, when I'm making this videos right now, as far as I'm concerned, we can't conceptualize what that means. What's the rate of the rate of the rate? We don't really know. After acceleration, after we analyze how the rate is changing, we don't really know what goes on beyond that. And that's fascinating, as that might lead into us understanding a little bit more about life in the future. So there's the video. I hope this helps you. So now you know what derivative is. Derivative is the slope function, but it's the function that represents the instantaneous rate of change at any given moment of that function f of x. All right. Hope that helps. Pretty awesome. Sorry I don't have the enthusiasm to match how awesome that is right now. All right, good luck.